Hi, everyone. My name is Yono. I'm going to have to do this fairly quickly because we have a lot of information to cover. I'm a machine learning advocate at DagsHub. DagsHub is a platform that helps you manage machine learning projects the right way. We provide workflows and tools for managing complex data projects, and including versioning and comparing data, labels, code, experiments, models, all in one place. If you see up here in the corner, there's a QR code that will take you to this link that's just below it. This is the repo where all of this information is coming from. This Jupyter Notebook is available in this repo, and you should be able to follow along after the talk. And I've documented it fairly well, so I think it should be fairly self-explanatory, but we're going to go through it fairly quickly so you can see what it is. The talk is called Active Learning Pipelines the Easy Way, or my alternative title was Active Learning in C Easy Steps. For those of you with a computer engineering background, or if you have 16 fingers, you'll get that joke. What is active learning, though? So active learning is a semi-supervised learning with a human in the loop. It differs from supervised learning in that instead of having the labeler or the human label all the data up front and then training a model, we label some of the data, and then we train a model, have the model determine which data should then be labeled next. And in doing so, we iterate in a cycle like this. And this allows us to create more accurate models faster with less data, saving us time and money. The repo that we're working with is called the Tiny Tooth Fairy. And this is a small toy project of a larger project that I worked on with a dentist. I am not a dentist. I don't know anything about teeth except for that you should brush your teeth every day and floss. So naturally, we need to have a dentist on board to help us be the domain expert in the labeling. And the kind of data that we're looking at here is X-rays of teeth. And so, of course, I could guess what those teeth are, but I don't know. So we have our domain expert label the teeth for us and tell us, draw polygons around them and label them so we know what they are. And that's what we use to train our model. Now, of course, a dentist's time is very important, very precious. So we can't just give him thousands and thousands upon images to label. That would just take forever, and it would eat away his time from actually visiting patients and stuff. So active learning is the perfect solution for this project right here. Additionally, on DagsHub, what you also get, in addition to being able to store your data here via DVC, we also have the ability to have the Label Studio server, which is what you just saw with the images. And we also have an MLflow server that's set up for you automatically, and it's available with every single repo, so that you can compare log and compare your experiments as you go along. Okay, let's get started into the meat of it. So this is going to be fairly quick. We have C steps to go through because it couldn't do it in 10. And we're going to start, like most programmers, we're going to start counting with 0. We're going to start by setting up our environment and importing the stuff that we need to do. If you fork the repo, be sure you change the repo owner, the user, and the repo to be whatever it is that matches what you forked from. From here, the only thing that you really need to pay attention to is there's a data source name. It's not important what it is right now, but just keep in mind that there is a data source name. Additionally, we have our images stored at data/images, which is at the root level of the repo. Finally, we also have a toSegmentation.json file, which includes Cocoa representations of our annotations because this was a convenient format to store it in, and we updated it as we went along. So this kind of already has all the annotations that we need for this project. We already performed the entire active learning cycle several times with our domain expert, our dentist, and we recorded all the annotations in this file. So what I'm going to show you here is a recreation of what we went through, but this entire notebook will work as the active learning pipeline if you're working from a fresh project. Additionally, we have a couple of interesting variables, max images and max score. These are going to determine how many images and which images we are going to send to the dentist for annotation during each cycle. And so maximum number of images, we don't want to send more than 10 in this toy example. And the max score is just the confidence level. We don't want to look at anything that the model is more confident than, say, 75%, because it's not going to learn as much from that. We want it to learn from the harder images, but we'll get into that a little bit later. If you're running this from Google Colab, you can just run this one, and it'll automatically set up your environment, including installing dependencies and cloning the repo. If you are not running in a Google Colab environment, it won't do anything, so you can ignore it. Before we import any other library, though, what we need to do is install DagsHub streaming. And this allows us to, rather than download the entire data set from our repo to our current locally cloned Git repo, this will allow us to stream that data so we can get started much more quickly. Additionally, we're going to import a bunch of dependencies. And the next imports are important ones. So at DagsHub, we created a feature called a data engine, which allows you to organize your data in various ways. It allows you to query your data, allows you to filter your data and attach metadata to your data in a very convenient way. And this is one of the two main aspects that allows you to create this active learning pipeline in a Jupyter Notebook. So there's a lot of features that we're going to show you today with the data engine. But the important thing to remember is that a data engine, the main construct around it is called a data source. And this data source has a lot in common with Pandas data frame. So it has a lot of familiar notation, a lot of familiar querying language with Pandas data frames. Additionally, it has some nice syntactic sugar that allows you to slice up the data set and then send it to annotation or to visualize it. We'll get to it a little bit later. Additionally, we're going to use Label Studio for our actual labeling, and that's also a very important tool in this workflow here. We're going to then import a couple more helper functions, which we'll get to as we need them. And then next, I mentioned we have an MLflow server attached to each repo where we're going to log parameters and metrics and our models, and this code just sets that up. Now we're done with step 0, on to step 1, where we're going to get or create our data source. Our data source, you'll see, was named earlier YOLO Vision for this conference. And I like to think of the data source name as kind of either an experiment that I'm running or a type of data that I'm trying to manipulate with this data set that I have. So for instance, here we're doing image segmentation. So I could create a data source called segmentation if I wanted to do all my segmentation work with it. If I was then using the exact same images for, say, object detection, I could create a separate data source with the name object detection just so I could keep them separate in my head and keep everything nice and clear. Or if, for instance, I was creating a captioning model for these teeth x-rays, I could create a clip model and then create a data source called clip so that I would be able to keep everything separated. Or if I'm iterating on a specific experiment, I could call them 1, 2, 3, and just so I could compare them later and see which ones I like better. The important thing is that the data source will allow you to attach metadata to your images, but you can attach multiple metadata through different data sources to the same images so that you can use them for different purposes. But what does this look like? So if we convert our data source to a data frame, what you'll see is that it looks a lot like a Pandas data frame if it runs. When I first got into speaking, a good friend of mine who was a speaker told me never do live demos; they're the worst. And apparently, I'm not doing him proud right now. So we're going whole hog in this live demo. This is what our default data source looks like. It has a path to the images, a data point ID, which may or may not be interesting to you, a URL where the image can be found into the repo, and then the size in terms of bytes. Next, we're going to create a bunch of data set functions, which will allow us to convert from Cocoa, which was in that JSON file, to our data engine format, which is very similar to Label Studio's format. But additionally, these data functions will also allow us to create YOLO format labels and a YOLO YAML file, which we're going to be using since we're training a YOLO V8 image segmentation model. These can all be found inside the utilities folder here, and they're just helper functions. They're not that pertinent for this, but just know where to look for them when you're going through this repo on your own. Now, we have, let's say our dentist has annotated 50 images for us to get started with. So what we're going to do is we're going to enrich our metadata for our data source by setting up the splits. So we're going to set 20 for training, 10 for valid, 20 for test in this example. And we're going to apply the annotations that the dentist provided for us using this create metadata function. And when we look at what this looks like, our enriched data set, which used to only have up to the size column, now we have the split column with train, test, and valid. We have some other metadata information that we need, like is this a valid data point, and what year YOLO format is this in? The annotation that we got from the domain expert, the dentist, and the categories, which are the labels that appeared in each image. After we're done with this, we can take this pandas data frame that we've created from our data source, and we can upload it back to DagsHub using this upload metadata from data frame. And this will store our information back on DagsHub so that we can use it at a later time. We're going to then, everything we've done up to now, we're only ever going to run once. Starting with step 3 all the way through step C, this is our active learning cycle now. So this is the part that we're going to iterate over and over and over again. The first thing we need to do is we want to get all of our labeled data. So we filter our data source by the annotation field, which is, if you remember, where we stored our annotations. And if the annotations are not null, then they're obviously labeled data. And if we check our length of our labeled data, we can see that it's 50, which matches up with our 20 train, 20 valid, and 20 train, 10 valid, and 20 test. And if you notice here, we can just verify that with this code right here. You'll see that the querying language for the data source is very similar to Pandas data frame. So if you're familiar with that, it'll be easy to transfer those skills over. Next, we need to obtain a model somehow. And now this is the portion of the talk where I'm going to simulate like a cooking show, where they show you how to prepare the entire meal. They put it into the oven and they immediately pull another one out that's completely finished because they cooked it before the show in order to save time. So what we can do is, since I've already gone through this process, I can load a model from our MLflow server, from our model registry. And I'm going to load the first model that I trained. And this will allow us to get through this process a lot faster. However, I want to show you how I trained the model. So let's go take a look how I created the YOLO V8 model in the first place. We have this helper function that creates a YOLO V8 dataset YAML. And I'm setting download to true. And if we look at the function in more detail, what we see is at first it downloads the data. It removes any old data set that wasn't there. It downloads the data into their train, valid, and test folders. Then it gets the annotation field from our data source, which I showed you where it was earlier, and it converts this into the YOLO style. So what this will do is it'll take the annotations and create a label file for each input image. After it's done that, in the appropriate directory structure too. After it's done that, it'll create a YAML dictionary called custom YOLO.YAML, which is what we'll use to feed into our YOLO V8 model to train it. Next, what we do is we add some custom callbacks using Ultralytics' add integration callbacks property here. And what these callbacks are going to do, these are going to allow us to not just monitor our training process, but also log it, basically using MLflow. So if we look at the callbacks that we have, we're going to tap into events that Ultralytics provides for us on pre-train routine end, on fit epoch end, and on train end. And what we're going to do is at the end of the pre-train routine, we're going to log our training parameters so that we can reproduce this in the future if we ever need to. At the end of each epoch, we're going to log the metrics for that epoch. And at the end of the training, we're going to not only log the artifact, but we're also going to register the model to our MLflow model registry, which will allow us to load it up the way I showed you earlier, using just 4 lines of code right here. So we have the model. We're not done yet. We're talking about training the model right now. So then, after we have the callbacks in place, what we can do is we can create our YOLO model. We have a function to get the device. So if you're running on Apple Silicon Mac, you'll get MPS. If you're running with NVIDIA GPU, you'll get CUDA. Otherwise, you'll get CPU. We'll start an MLflow environment, and then we just run model.train using Ultralytics YOLO V8's train function. We pass it the data set. We want it to say run for 50 epochs with our device. And those callbacks that we added earlier will automatically ensure that we log our parameters and metrics during the whole training run. After we're done, we have this log test set. So what we can do is we can actually load the model using the MLflow model registry. We can run the test set on that model, which was the best model that we trained on. That's the best model produced from the training. And we get the metrics dictionary from that, and we can log that back to our MLflow server. This way, we'll be able to compare models and runs across time, which is great. Reproducibility is always very important. All right, we've got a model now. We've trained it or we've loaded it. What we need to do now is we need to use this model to determine which data we want to send back to our domain expert to be labeled next. So the overall idea is the model should figure out what the most complicated data it has. So the data it has the most trouble labeling, it's going to give us a very low score for those, or a confidence threshold. And we'll then choose the worst ones and then package those up to send to our domain expert. So the first thing we need to do is we need to grab all the unlabeled data by filtering our data source on annotations which are null. We have 45 of them because we have a total of 95 images in our directory, and we had 50 for our initial run. And the unlabeled data looks like this. Again, live demos. It looks exactly like the other data did because it has no annotations. Next, what we want to do is we want to run inference on all of the unlabeled data. So we can't figure out which ones it has trouble on the most until we've run it on all of them. So we have a loop that we can grab the DagsHub download URL. And because YOLO V8 supports passing in a URL into the model, we can just pass that directly into our model to run inference. We do something with the results, and then we remove when YOLO V8 downloaded the model, the images, it downloaded to the local repository. So we just remove it to clean up the thing so we don't pollute our repository. There might be a better way to do this, but this way works for right now. And what we'll see is once it's done with everything, our length of results will be 45. I'm going to continue on because we're low on time anyway. The next thing we have to do is we have to enrich the data source with these predictions that we've made. And there's two easy options. We can take the lowest confidence of the objects detected in the images, or the average confidence. In our case, we're going to use average confidence because it makes a little bit more sense in this case. There are more complicated scoring mechanisms that you can use, but they're harder to implement. But on the other hand, they might give you better results overall and allow you to achieve higher accuracy faster. We're going to convert all of our results to the data engine format, which I said is like Label Studio. And we're going to add these to our metadata. And we're going to add the predictions under a prediction column, a new prediction column similar to the annotation column. And we're going to have a prediction score. And when we enrich the prediction, you'll see it looks basically like this. We add a prediction column and a prediction score, just like I promised. And we send these back up to DagsHub for safekeeping instead of keeping everything local. The next thing that we want to do is we want to sort our data source by confidence and choose our top or our worst X samples. So in this case, what we do is we filter out by anything that doesn't have an annotation and anything that has a prediction. Because if something failed on inference, we want to make sure that we have the prediction to go along with it. You'll see right now the prediction looks like hashes, even though here it looked like data. This is because it downloads them to a separate file, and what we'll have to do is run a separate function in order to insert the data back into our data frame here. But right now we're interested in the prediction scores. So what we do is we pull out all the prediction scores from our data frame. We sort them. We filter out anything less. We filter out anything greater than the max score, and we take the final one as our threshold score, which is 0.496. If we use this now to filter out our data source, we will get exactly the right number of images we want to send to our domain expert, which was 10 in this case. And these options to label look like this. Next, I told you, so this toLabel is actually a query data source. And I told you there was a lot of syntactic tree that we added to data sources that allow you to do special things. One of them is we can send these to Label Studio to be annotated. So this .annotate function helps you create a Label Studio project. When you click on that, Label Studio is supposed to be running. Unfortunately, live demos, I think I've talked about why it's not a good idea. Generally, what you'll be able to do is you'll be able to create a new project on Label Studio using this. And then what we would need to do is we would need to send our predictions to Label Studio before we can send it to our domain expert. What this will do is we have a helper function to get the tasks. Label Studio is where DagsHub is running a Label Studio server for each repo. We are able to connect to the tasks API to get the tasks via this API. We can get our Label Studio client based on the URL for our repo and a bunch of information that we set up at the very beginning. And then when you created the Label Studio project earlier, you were going to give it a name. And in this case, we called it cycle 1. Whatever name you gave it, you'd want to put it here. And we can go through all the projects in Label Studio and get the one that matches cycle 1. After that, we can get our tasks. And then what we can do is we need to, unfortunately, I'd like to show you what the task looks like, but the important things to remember from the task is it has a task ID and it has a data image. The image is a URL, which matches the URL that's in the data source data frame that you saw earlier. So the URL is our link between the tasks and our predictions that we created. So we want to create a dictionary to be able to map from one to the other. We get all of our predictions. And this function right here, the get blob fields, would load the predictions into memory. So it would convert those hashes into, I think this we can actually run. It'll convert the hashes into the actual predictions that we had before. And if you see the data frame, we now have those predictions in place. Next, we convert these predictions into a Label Studio format, which includes just basically the result that we got from the prediction, our confidence score, and the task ID from that URL to task ID map. After this, what happens is we would create we would send these predictions to Label Studio, which would allow us to then create a URL. Oops, yeah, because I didn't run some of the other stuff before. But what this would allow us to do is create a new project. So this is our cycle 1 project using our previous settings. But this will allow us to create our tasks via Label Studio, and then send them to our domain expert for labeling. Once the domain expert has labeled the what he would see is he would see predictions right here. We haven't sent the predictions, that's why you don't see anything here. But if we could say go to this is essentially what it would look like. If the domain expert then starts modifying stuff, they can update. They can update each individual polygon if they want, and then when they hit, after they've fixed the predictions to match the what they feel is the correct ground truths, when they hit save, it'll save that data to the annotation column in the data source. Once we've saved the data to the annotation column, this essentially allows us to go to 3, which allows us to continue, which allows us to start the next cycle of active learning, meaning we will filter out by annotation. This will be 60 instead of 50, and we'll have 30 training instead of 20. And then that would be cycle 1, 2, 3. As an example, what I did, I ran for 3 cycles earlier yesterday. And as you can see, all the metrics were improving across the board as we added the harder and harder data points to our training data. Okay, sorry, that was a lot of information. I hope that made at least somewhat of sense, even though the live demo failed for a certain point of view. I hope you enjoyed it. Let me know if you have any questions.
But first, a huge round of applause for Yono. That was a powerhouse demo. Absolutely amazing. Yes. Brilliant. And if anybody has a question that happens to be, can I have a delicious coffee? The answer is yes, because we have coffee at the back of the room, my friends. But we do have a little bit of time now for questions with Yono after that incredible live demo. I was convinced the Tooth Fairy exists, and now I know it's true. And now he's seen the Tooth Fairy is alive and well and hanging out with Yono Mittlefehldt. So brilliant stuff. Do we have any questions? Questions from our virtual stream there? DJ Talia, what do we got?
Yes. Can this project be done in the community tier, or is it only for paying users?
Oh, we lost your sound again. Sorry, mate.
All right, how about now? Are we good?
I think you are muted.
Oh, you might be muted.
Okay.
That's my
Now it's okay?
technical advice goes. Oh, hold on, what was that? Hello?
Can you hear me?
No.
Can you hear me?
Hello?
Hello?
Yes, we hear you now.
Oh, okay. All right. Wow, this is a trip. Yeah. So the data engine can be used with the free community tier. It is only available in public repos for the free community tier. If you do need availability on the private repos, you do have to become a paying customer for that. But it's still extremely powerful, and it's amazing what you can build in a short amount of time with that, I think.
For Yono.
Yes. Can you run this pipeline on a subset of the data to improve the model for a specific task?
Yes, exactly. So at the very beginning, I was sorry, I was talking very fast, so it might have been hard to hear. But you can create a data source for each specific subtask. So you can have a data source for segmentation, you can have a data source for captioning, you can have a data source for object detection, and then you can use those separately and keep all of your metadata essentially separated and train models on each one separately like that. So it's definitely possible.
I love it. In-depth questions. We have a very, very well-informed group of people joining us via the live stream. Hello, and thank you for your amazing contributions. I'm learning so much. I'm arguably starting from a lower point. Talia, do we have any more questions?
Yes. One last question. Tell us about your approach to ML project planning.
Yeah, that is a very good question. I feel like my feelings on ML project planning evolves over time. Every time I learn something new, I incorporate it into my project planning. But I am a very strong believer in reproducibility. So if you can't reproduce what you've done, it's kind of pointless. So I tend to log everything. I use MLflow to log the parameters I use to train the model, the metrics with the model so I can compare them. I make sure that no matter what, I can go back to a specific point in time and reproduce what I did before. Otherwise, I have no idea if what I'm doing is moving my my model forward and improving accuracy if I don't know where I came from, I guess, if that makes sense. So for me, it's very important to take very good notes and to log everything.
Sage advice there. And a perfect note to round up our great presentation. We've been talking about hashtag YOLO. We've now got hashtag Yono. Thank you so much to Yono Mittlefehldt and the Tooth Fairy for showing us some great magic and a brilliant live demo there. Big round of applause for Yono. Thank you so much. Outstanding. And if you're feeling the love, if you're learning a lot, if you're impressed, remember to share those thoughts online on any of your social media channels. Use the hashtag YV23. And of course, reach out to Yono and any of our speakers online, and let's continue the conversation. Okay.